Today we are going to talk about the neural networks and the deep learning. As you know that machine learning is a big umbrella, or let's say the AI is the big umbrella, and then within the AI there is subset called machine learning. And you have taken the machine learning part, and then part of the machine learning there is what's called deep learning. So deep learning mainly it's based on the neural networks. So today's lecture is going to be focused on first we give some introduction about neural networks, and then how to form the neural networks. Then we talk about deep learning and its comparison to the machine learning, followed by basic types of neural networks. Then we talk a little bit about activation functions. And activation functions is very important within the neural network architecture, because it will convert the model from linear model into nonlinear model. So once become a nonlinear model, it can solve more complex problems. And then the transfer learning. Transfer learning is very, very, very important, because with transfer learning, we don't need to train the deep learning from scratch, but we could use the pre-trained deep learning system, and then we train it further for the specific application. Okay, so let's start with the neural networks. As I said, the deep learning, remember, deep learning is based on a neural networks, which is simply they called it as a neural network, NN. So the idea of neural network, we first it has been established a long time ago. Neural network in last century, then it got some momentum starting from the 1980s of the last centuries, and in the last 20 years or so, it becomes very important because of the advances in the speed of computation and the large size of memory in a smaller area. Because, neural network is based on the training. So since it is based on the training, it means it needs a lot of processing time. So that's why in the before 1980s, the speed of processing was very small, very low, and nowadays we have got huge advances. So that's why with the advanced manufacturing of GPUs and the supercomputers, neural networks becomes more feasible, and that's why most of the AI models are based on deep learning. The basic, we're going now to talk about the basic structure of the neural network, which is the neuron. So the neuron, and remember, the neural network, we developed the neural network based on the neurons in our brains, the human brains. And as you know that in the human brains, there are about 100 billions neurons in our brain. And these neurons are fully connected. They are fully connected, and the basic element of the neurons in our brain is called soma. So soma is the core of the neurons, and then the input to this soma, or to this neuron, we have many inputs, and they call it in our brain dendrites. And these are many. So many of them. So the basic structure of the neuron in our brain, the core is called soma, which accepts many connections from other neurons in the brain. And these are called dendrites. And then we have a single output. So remember, the neuron has many inputs, multiple inputs, but single outputs. And we have multiple outputs. And this single output is called axon. So each neuron in our body has got soma, which is the body of the cell of the neuron. It's a single cell, definitely, and then gets connection from other neurons. These connection called dendrites. So the axon will go to many other neurons. So in these cases, the axons will go to be as a dendrite. So one dendrite, and goes to another soma, and so forth. So this is actually the basic structure of the neurons in our body. So the scientists say, okay, since the brain is the most intelligent device in the world, so that's why, as engineers, we thought about get the same structure of the brain and neurons, how they are connected, but we make what's called artificial neural network. So usually sometimes we use A at the beginning to to refer to that this neural network is not the one natural neural network, but artificial. But even if you omit this, that's not a problem. So NN is fine. So in the literature, in the textbooks, you might find NN only, a neural network, or you could find ANN, which stands for artificial neural networks. Okay, so this is actually what's happening in our brain. So what we did, we modeled this. So we modeled what's happening in the brain, and we developed artificial system. And the artificial system going to be implemented in computers. So usually is in a software, and there are a lot of software available nowadays. So in this case, we have the neuron that has several input. So for example, if I have a simple problem, x1, x2, for example, and the output is y. So usually what we did actually as engineers, scientists, computer scientists, we get the modeling of the brain and we say, okay, let's assume that this is a summation. So we get all the inputs for the system to the neuron, and we sum it. So in this case, we say x1 plus x2, or x and to make it more general, xi, and then I could start from 1 in this case to 2, or in general to 2n. And then the y could be y equal summation of xi, I from 1 to n. However, this system is linear system. And you know the linear system only can solve linear problems. So that's why they add activation function, certain function, for this output. So the y becomes now a certain function of the summation of the output. By this, so this is a linear system inside, but as a whole now become nonlinear system. Depends on the function. So the function, if we make it like, nonlinear function, so the nonlinear function will convert this linear function into a nonlinear function, and then y becomes nonlinear. There are a lot of this FF, we call it activation function. So this activation function, there are many types of them. We'll talk about the various type of them, but one of the earliest functions is called sigmoid. So actually sigmoid or linear rectified function going to be like this. So some function like this, activation function 1. Another activation function could be like this. And this is the sigmoid. So this is activation function 2. And then, as I said, so this one is nonlinear system, because whatever here will be truncated, and then only. But this one actually this function mainly for deep learning, and this one is for the neural network. Okay. So actually these some basic concepts of neural network. So now we will go to the architecture of neural networks. This is a very basic architecture, which is the single neuron, but usually to solve complex problems we need many neurons. Could be tens, hundreds, maybe thousands, and so forth. So okay, now as I said, we want to go to more showing you different types of neural network. So here we will have to have single layer feed forward as the basic neural network. In this case, we have, for example, this is called single layer feed forward neural network. So the single layer feed forward neural network has got many inputs. We are going to just show you one very simple could be x1, x2, but could be more than that. Okay, so let's say x1 and then xn. This is to see that we could have only x1, x2, x1, x2, x3, and so forth. So these are the input of the neural network. And then the output layer, again, could be many neurons at the output layer. So this could be y1, and this one could be ym. Just to distinguish it, because this is not necessarily to be the same. Could be here 2, and single output. Could be here 100, single output. 100, maybe 2 outputs, and so forth. The idea is that neural network is fully connected, although it might be not fully connected in various designs. So in this case, the output of this neuron will go to all neurons in the for the next layer. Okay, and the same for this one. So maybe I could put some different color to make it clearer to you. So this could be goes to here, and the output goes to here, and again to all neurons in between. Okay, so this is actually called single layer feed forward, because this is the input and this is just the output. So that's what they call the single layer. While the other one called multi-layer neural network. In multi-layer we have more than one layer. And then so this is called the input layer. This is called hidden layer, and this is called output layer. And again, it's fully connected. So for example, this one, same as this one. Here it is connected to all. This one connected to all neurons in the next layer. And the same for all neurons here. It will be connected to all neurons in the next layer. Similarly, and this one as well. So in this case here, for this architecture, it can only solve very simple linear system, very simple problem. But here, by adding hidden layer, actually we're adding more dimensionality to the complexity of the problems. So maybe this one could solve one-dimension system, one-dimension problem, complex problem. Here we could have multi-dimensional complex problem can be solved with this. And remember, the neural network is based on training. So usually there is something I need to mention to you, that here there is some weight. Okay, so there are weights. So this value doesn't go directly to this one. It will multiply by Wi. So the input here will be equal XW. And the same here. So whatever W, for example, here would Wi, W1 in this case, Wi in this case, and Wn. And this what makes the how we could generate different weights. With different weights can solve different problems. And the same here, all of them has to be multiply by weights. And the basic concept of training of neural networks is to train the system so usually we initialize these weights by certain values, and then we train them until we get the right result. Once we get the right result, these weights will be fixed. So in the training phase, these weights keep changing. Once the system trained, the weights will be fixed. Okay, this is very important for you to understand. So the basic concept of a neural network is based on neurons and the connection between neurons and generating multi-layers, and then do trainings. Training means changing the weights between the several neurons. And this weight, indicates to the strength of the connection between this neuron to this one. Okay, so the higher means there is a strong influence of this neuron on this. The lower means less influence of this neuron on this one. And this is very important for you to understand. So as I mentioned, here is the input layer, hidden layer, and this one, the output layer. And I think this is very clear to you. And it's not necessarily to be single hidden layer. Could be multiple hidden layer. And the more hidden layer means the complexity of the problem can be solved better. And that's, remember I mentioned deep learning, and deep learning is based on increasing the number of hidden layers. So deep learning system basically it's a neural network with large number of hidden layers. We mentioned something about the training. So training means that I show some examples. Examples means like, for example, let's assume we have only two input, x1 and x2. So examples means example 1, for example 1 could be x1, could be 0.1, 0.3. So the various values of the inputs shows us several examples. And usually we try to make the inputs maximum 1 so that there will be no explosions of the values. So the idea of training, we expose the neural network to various examples, and for each example, for example, we expect the y to be, for example, here 1, and for here to be, for example, 0. Okay, and this one called the YT. So YT means the ground truth, means the right value. So usually with the supervised learning, although there are another type called unsupervised, but the most common is the supervised learning, we train the system, we put the input x1, x2 as 0.1, 0.3, and we see what are the value of, for example, if we, for example, say we have only a single output. Okay, so for example, this is hidden layer and this is output layer. So the output layer is one value. Okay, and this is x1, x2. So the truth, during the training, we expose this with, for example, 0.1, 0.3 here. and then 0.1, 0.3, and the output should be, for example, 1. That the ground truth should be 1. But initially when we put some weights, which is different, various values of weight, when we experiment with them, we will not get at the beginning 1. We get something different. So that's why with the training, we need to try several times until we get the right output. So usually you have the predicted one. So for example, at the first step of training, we expose 0.1, 0.3, but we get, for example, here 0.5, which is not right. So that's why we need to apply a training algorithm. One of the most popular one called backpropagation, to change the values of W. Because as I mentioned, the training is based on the changing the values of W. And one of the most common method of correcting the output until we get is the called mean squared error. I'm sure you are familiar with it. So mainly the mean square error for this sample will be the 1/2, and then we have the summation of the error. It depends on the number of samples. So here we have I equal 1 to n, and then the more we train, we have the yt, which is the ground truth value, y minus the yp. So we are summing the difference between the expected and the actual. And by summing the square, and usually we put squares to just use the positive values. So even if there's a negative values, it will be converted into positive value, because we are not interested in this sign of the difference. We are interested in only the value of the difference. So usually we use the mean square error in our training. And the idea here now, the ultimate idea is that we need to minimize this. So that's why the idea of training is it's a minimization problem, or we call it optimization problem. Because optimization means get the either maximum or minimum, but usually with the neural network we get the minimization. And in another word, we need to get the minimum value. So in this case, the system we get could be like this. The main idea of the training is to get the what's called global minimum, as opposed to local minimum. So the good system model that you create is your training is stabilized not here, not here, not here, but to the global minimum. So this is actually the concept of the training. Okay, so now we'll go to this is a very simple example of the way we calculate the MSE. I'm sure you are familiar with it, but anyway, let's put it. We have for example, the xi, y, the truth table, the actual we call it sometimes, and this is the predicted. I mean the target, sorry, this one the actual. This one, T stands for the ground truth, P stands for the predicted one. And then the summation of difference, mean square error, mean squared error, going to be yt minus yp squared. So this is just an example to show you how to, for example, if we have, for example, here certain input 1 to 10, for example, targeted should be 1, 0, whatever yani here, 0, 1, and the UP. But actually, as I said, usually when we train, we get 0, we might get here 1, we get 0, 1, something like that. And then the difference is like 1 minus 0 here 1, 0 minus 1 is the minus 1, but because of square becomes 1, and that's the idea of adding square. So the mean square error is just the summation of this. Okay, this is just to show you an example. I'm sure you are familiar with mean squared error. Now we go to the remember the original architecture, always keep it in mind. Subset of AI is machine learning, and subset of machine learning is deep learning. So now we see the comparison between machine learning and deep learning. So here we say, for example, factors. We're looking at factors and see the difference between, for example, deep learning and machine learning. So, for example, of size of the data, deep learning will require, let's say, big data, while machine learning not necessarily. Small is okay. For training time, definitely deep learning high, while machine learning low to medium. For computational, yani CPU requirement, here we use GPU. But machine learning CPU is okay. For flexibility and tuning, here definitely we need high flexibility, because we have to make sure that we are train the system in the right way, while for machine learning is very rigid, very limited with the algorithm. So that's why deep learning we get much better result. For the type of output, deep learning could be any form, no problem, while the machine learning is limited to the numerical. The algorithms, as I mentioned in the beginning of the lecture, the algorithm of deep learning based on the human brain. While the ML based on statistical. statistical base. So that's why it's very limited. Here it's unlimited. So now we'll go to show you more about the difference between the machine learning and deep learning. So, for example, for machine learning, if we have some input, for example, an image of a car. And we want to recognize this as car or not car. Okay, so this is for machine learning. So in this case, we need first, before using the neural network, we need to develop an algorithm here for feature extraction. And then the input is the image of the car, and then we need to identify some feature to be designed by the developer or programmer, and then the output of the features extraction will go to the neural network. So first the image goes to feature extraction, which feature extraction is very complicated and time consuming because it's going to be manual. It has to be done by the expert in programming or algorithm development. And for example, in this case, the image processing. And then after that, we get the output of these features, whatever number of features, could be 10, 15, 20. Then we feed it to the neural network, and then we get the result. And the result could be like, 1 for car, 0 not a car. So this is actually machine learning. While for deep learning, same, we have the image of the car, and then as input. But in this case, directly goes to the what's called deep learning system. And the output will be 1 car, 0 not car. So now you wonder why in this case, because in deep learning we have a lot of layers, and we can design some of the layers as implicitly as feature extraction. So that's why the deep learning is a combination of these components. So it is feature extraction, and classification. So we are combining the feature extraction, which is a separate component in ML, while the classifier as another component in neural network. And that's why the deep learning is more powerful, because it can automate the feature extraction. And the feature extraction not just on one level, at several levels. So for example, for image, could be at some of the layers in deep learning identify low level of information features such as lines or something like that, while the other level, the next level, to identify certain pattern or something like that. So for example, for cars, identification for at the beginning lines, and then shapes, and then the whole shape as a car or not car. So now we talk about the process of deep learning. So the process of deep learning, we have, for example, a component of data collection, and then pre-processing, and then feature extraction, deep learning. And this deep learning, as a component, we got the training, and then after training we go to testing, and after testing is the final product deployment. So this is actually the process of deep learning. Okay, so next we are going to look at the various types of neural networks. So there is one type called feed forward neural network. This type means, from its name, going from left to right. So the information going from here. So this is the input, and then this, as we said, we go to all of them, and the same for this. Then we get that. So this one in this direction, and that's why I called feed-forward neural networks. And usually, for each neuron in this component, we have the summation, and then there is something called bias, in addition to the inputs. So these are summed all together, and then we go to the activation function. So for example, this sigmoid is very popular, and then we get the output. And this one could be one output, two outputs, depend on the problem at hand. We can see some, for example, pros and cons of the neural network, deep learning. Good, it's could like solve a problem by training. That's a good thing. Second, the activation function convert linear system into nonlinear system. So in this case, more wider range of application can be solved by the nonlinearity in the neural networks. And definitely, as I mentioned before, the Nonlinearity comes because of the activation function. Because the summation generates us a linear system, with the activation converted into a nonlinear system. Disadvantage, actually, the first advantage of the could be like, by neural network, the training parameter could be increased. So, for example, if we have tens or hundreds or thousands or layers, the number of parameters that to be trained will be an increase of number of parameters. This is first cons. Second cons, this is a major problem for the deep learning neural networks, called vanishing and exploding gradient. So in this case, the weights of the neural network are updated through this actually, this one actually is related to the training algorithm. So, one of the most popular one is the backpropagation. And with backpropagation, do the training by getting the information, the result or the errors back to the earlier stages of neural network to make corrections to the parameters. And that could lead to a vanishing and exploding gradients. For the types of neural networks, as we said, we have feed-forward, and the second type is first type. The second type is the recurrent neural network. The recurrent neural network, we have, like, this single layer, and it's fed back again. That's why the name comes recurrent. So it's fully connected on this side. And then we get the output. So this type called the recurrent. The good thing about the recurrent neural networks, it captures the sequential information present in the input data. And definitely the recurrent neural network share the parameters across different time. So when there is a time series or application, it will be very useful, the recurrent neural networks. The disadvantage of deep recurrent neural network, that with large number of time steps, it again suffer from the vanishing and exploding gradient, which is common to all types of deep learning. Another type, which is also very important as part of the deep learning, is the convolutional neural network. This convolutional neural network mainly to capture the features at various levels. So CNN is very useful for automatically extracting the features, mainly the spatial features. Okay. And again, similar to the RNN, she has parameter sharing. Convolutional neural network is the disadvantage is sensitive to the selection of activation function. Yeah, okay, now we will go to see the comparison between the artificial neural network, convolutional neural network, and recurrent neural network. So we're going to generate a table to show so that you could understand the comparison, and then when you want to decide which type of neural network, you'll have the right decision. So these are the factors affecting as we did before between machine learning and deep learning. Now we are doing it with the feed-forward neural network, convolutional neural network, and recurrent neural network. So first factor is the type of data. What type of data that suit these models or types of neural network. So for data type, when I say data type, I mean the problem at hand, that domain. So for forward, tabular is most useful data type. So tabular is very useful. And then for convolutional neural network, definitely is for images. And when we talk about images, we're talking about matrices. For recurrent neural network is useful for audio and video. So in this case, well, this will help you to make the decision regarding which type of, what kind of form of training form. As you know, we have supervised and non-supervised. For all of them, it's actually the same, both supervised and non-supervised and supervised. So both of them can be applied to this to all types of neural network. For the type of the application. So usually for convolutional neural network classification, while for the recurrent neural networks regression. Okay, for the presence of recurrent information connection, definitely these are negative, and here we have a positive recurrent information. About sharing parameter, so here negative, Here we negative, but here we positive. So as we mentioned, convolutional neural network, the recurrent neural network, they have sharing information. For spatial, definitely only the convolutional neural network we have. Unfortunately, for vanishing and exploding gradients, all of them is this problem exists in all of them. Okay, so I hope that you have a good understanding of the first part of the introduction of neural networks. Hopefully in the next part of the next lecture, we'll go and discuss more. Thank you very much.